So guys, this is the session number one of differentiability and continuity chapter. Okay, so let's take up some problems from the exercise. Okay, and this chapter has been covered up earlier in class as well. So this is just a revision session. Okay, so exercise 7A from OPM. Let's go to question number three. Okay, so f of x is equal to x square minus 4x plus 3 upon x square minus 1. This is x is not equal to 1. Okay, and f of x equal to 2 when x is equal to 1, right? So we need to test the continuity at 1. Okay, now not equal to 1 indicates greater than 1 as well as lesser than 1. X not equal to 1 meaning is greater than 1 as well as lesser than 1. So we have to discuss the continuity at x equal to 1. Okay, so let's take left hand side limit x approaching towards 1 minus. Okay, so 1 is over here, x is approaching towards 1 from the left hand side. Okay, so 1 minus because one smaller value h, a very small value h will be subtracted from 1 such that it is not equal to 1 but then very near to 1 from the left hand side. Okay, so 1 minus is x less than 1. So which function is there for x less than 1? Okay, it's this one. Okay, so x square minus 4x plus 3 upon x square minus 1. Okay, now this is 1 minus. So let x is equal to 1 minus h. As x approaches 1, h will approach 0. The point when x becomes 1, 1 will get cancelled and h will approach 0. Okay, so this is equal to limit h approaching 0, 1 minus h the whole square minus 4 into 1 minus h. Okay, plus 3 upon 1 minus h the whole square minus 1. Fine. So we are going to simplify this. 1 minus h the whole square is 1 minus 2h plus h square expansion of a minus b the whole square minus 4 plus 4h plus 3 upon 1 minus h the whole square. So that is equal to 1 minus 2h plus h square minus 1. Okay, so 1 and minus 1 in the numerator. 1 plus this 3 is 4, 4 and this minus 4 is gone. So now limit h approaching towards 0. Okay, in the numerator it will be h square plus 2h. Okay, and down it is going to be h square minus 2h. Okay, so take h common, h plus 2, h minus 2. Okay, so this and this is getting cancelled. Now we cannot further simplify this, so put the value of h as 0. So this is minus 1. 2 upon minus 2 is minus 1. Okay, so this is the left hand side limit. Let's take the right hand side limit. RHL limit x approaching 1 plus, okay, x square minus 4x plus 3 upon x square minus 1. Okay, 1 plus is greater than 1. Now x greater than 1 is which function? The same function. Okay, so let x is equal to 1 plus h. As x becomes 1, h becomes 0. So limit h approaching 0, 1 plus h the whole square minus 4 into 1 plus h plus 3 upon 1 plus h the whole square minus 1. Okay, again we are going to simplify this. Limit h approaching 0, 1 plus 2h plus h square, okay, minus 4 minus 4h plus 3. Down also 1 plus 2h plus h square, okay, expansion of this minus 1. Fine. So here 4 and 4 is gone. Down also 1 and 1 is gone. So this is going to be limit h approaching 0, h square minus 2h upon h square plus 2h. Take h common. Okay. So h and h is getting cancelled. Now we can put the value of h as 2. So the answer is minus 1. The left hand side limit and the right hand side limit, both answer is minus 1. Okay. But then at x is equal to 1, it holds a different value. Okay. That is 2. Fine. So I'll conclude LHL equal to RHL, but then LHL not equal to f of x is equal to 2. RHL is also not equal to f of x equal to 2. X equal to 1, sorry, not 2. Okay. All three should be same. Therefore, f of x is discontinuous at x equal to 1. Clear? So this was a very basic problem of limits, the first problem. Okay. And it was question number 3 from the exercise. Fine. So let us go to question number 13 from the exercise 1-3. So f of x is equal to, this is 13 sub question A. F of x is equal to tan 2x upon 3x. X is not equal to 0. X is not equal to 0 is x greater than 0, x lesser than 0. Okay. And f of x is equal to 2 by 3 when x is equal to 0. When x is equal to 0. Okay. So we need to test the continuity at x equal to 0. So 0 is a critical point obviously over here. Okay. So we'll start with LHL. Limit x approaching 0 minus x is less than 0. So for less than 0, which function is there? Tan 2x upon 3x. Okay. So let x is equal to 0 minus h. Okay. As x approaches 0. Okay, because x is approaching 0, right, in the problem. So h also approaches 0. So limit h approaches 0, and whenever there is x, put 0 minus h. Okay, limit h approaches 0, tan of minus 2h and minus 3h. Now tan of minus x is minus tan x. So minus and minus is getting cancelled. So this is tan 2h upon h. Now if you remember grade 11, the angle of tan, whatever angle is there, the same angle should be down. So now there is 2h over here. So denominator should also be 2h. So what we will do is limit h approaching 0 will make the denominator 2h. Okay. So we are multiplying and dividing by 2. And this 3, I'll just write it over here. Okay. So this part, the pink colored part, is 1 into 2 by 3, which is 2 by 3. And one thing you write it for the paper corrector, as h approaches 0, 2h also approaches 0. Make sure that you're writing this for the paper corrector. Okay. Fine. We'll start with RHL. Limit x approaching 0 plus. 0 plus means x greater than 0. The function remains the same. Okay. So I'll just write let x is equal to 0 plus h. As x approaches 0, h will also approach 0. So we're changing the limits from x approaching 0. It is h approaching 0. Tan 2 into 0 plus h, 3 into 0 plus h, which is equal to limit h approaching 0, tan 2h upon 3h. Now again, this is 2h. So in the denominator, again we need to have 2h, because that is the criteria for sine and tan term, tan formula in limits. Okay. So tan 2h. Now this h is there. Okay. Now make it 2h, multiply and divide by 2, and this particular 3 is written over here. Okay. So this part is 1 into 2 by 3. Okay. It is the direct formula, which is 2 by 3. Okay. And one thing you write for the paper corrector, as h approaches 0, okay, 2h will also approach 0. Fine. Yeah. Now this formula is applicable only for sine and tan. Okay. And the value should approach 0 and no other value. So LHL and RHL are same. Okay. Now we need to write down what is f of x equal to 0, and that is also equal to 2 by 3. So LHL equal to RHL equal to f of x equal to 0. Therefore, f of x is continuous at x equal to 0. That should be our conclusion. Okay. So let's go to question number 13. Sub question B. F of x is equal to 1 plus modulus of x upon x for x not equal to 0, and f of x is equal to 1 for x equal to 0. They have given f of 0 equal to 1. So this is the value of x. Okay, this 0 is x. When x is 0, the function is 1. Right? So this again, it is x greater than 0, x lesser than 0. Fine. So I'll start with LHL, left hand side limit, and we have to discuss the continuity at x equal to 0. It's given in the problem. So x approaching 0 minus 0 minus is x less than 0. The function remains the same. 1 plus modulus of x upon x. Let x is equal to 0 minus h. As x approaches 0, h will also approach 0. So limit h approaches 0, 1 plus 0 minus h upon 0 minus h. Limit h approaches 0, 1 plus modulus of minus h upon minus h, because 0 minus h is minus h. Now modulus of minus h is h, and this is minus h. Okay, so 1 plus and minus will become minus, h will get cancelled. So this is equal to 0. Okay, so here LHL is equal to 0. Okay, now ideally we don't require RHL because LHL we got 0. Okay, and f of x equal to 0 is 1. Both are not same. Okay, so ideally RHL is not really required because LHL is not equal to, and just write over here, f of x equal to 0. Therefore it is discontinuous at x equal to 0. Fine. But then for your exams or to be on the safer side, you also mention RHL for the sake of calculations. Okay. Now in the same exercise, let us go to question number 19. Okay. Let's go to question number 19. So f of x is equal to 1 minus cos 2x upon 2x square. X is not equal to 0 and f of x is equal to k when x is equal to 0. Now in this problem, they have given that the function is continuous at x is equal to 0. It is continuous. We don't have to prove. They have given it is continuous. We don't really have to prove, unlike the previous problems. So we'll just write since f of x is continuous at x equal to 0, LHL equal to RHL is equal to f of x equal to 0. Okay. So f of x equal to 0 is nothing but k. See, x equal to 0 is k. So this k will be equated to either LHL or RHL. So in this particular problem, you can solve any one, either LHL or RHL, and equate it with k. That's how you'll get the value of k. So I'll take RHL. You can also take LHL, not a problem. Okay, so RHL limit x approaching 0 plus x is greater than 0. In the question, the function is same for both LHL RHL. Okay, right? For greater than 0 also the same function, lesser than 0 also the same function. 1 minus cos 2x upon 2x square. Let x equal to 0 plus h. As x approaches 0, h will also approach 0. So limit h approaching 0, 1 minus cos 2 into 0 plus h upon 2 into 0 plus h the whole square. Fine. Now limit h approaches 0, 1 minus cos 2h upon 2h square. Now this is TF 2 sine square h. Okay, half angle formula. So this 2 and 2 will get cancelled. So we are left with sine square h upon h square. Now what we'll do is limit sine square h upon h square. So we'll just take the square outside over here. Now see sine of h upon same h. So this is 1 provided this is 0 over here. Okay. So this is 1 square. So from 1 k is equal to 1 because LHL or RHL is equal to k in equation number 1. So k is equal to 1. Okay. Yeah. Now uh, let me see which problem is supposed to be done. Okay, question number 20. From the same exercise, f of x is equal to x upon modulus of x plus 2x square. X is not equal to 0. This means x is greater than 0, x is lesser than 0. Okay. F of x is equal to k when x is equal to 0. Now they are asking us to prove that the function is discontinuous at x is equal to 0 regardless of the choice of k. So we need to find out LHL. Second, we need to find out RHL. Third, f of 0 x is equal to 0 is equal to k. So all three things should be same. Okay. So first, and this problem we are proving whether it is continuous or not. Okay. So LHL limit x approaching 0 minus where x is less than 0. Okay. X upon modulus of x to x square. Let x is equal to 0 minus h as x approaches 0. Okay. As x approaches 0, h will also approach 0. So limit h approaching 0, 0 minus h, modulus of 0 minus h, 2 into 0 minus h, the whole square. Now, don't really substitute the value of h as 0 because first we'll have to simplify this. So minus h, modulus of minus h plus 2h square. Okay. Now modulus of minus h will be h. So limit h approaching 0 minus h plus 2h square. Limit h approaching 0 minus h upon, take h common. So this will be 1 plus 2h. Now cancel one h. This can be cancelled. Okay. Now put the value of h as 0 because we can't really do anything after this. Whatever simplifications were supposed to be done are done. So LHL is minus 1 by 3. Let's start with RHL. Right hand side limit. The function remains same. Okay. Because not equal to 0 indicates what? Both greater than as well as lesser than. So x upon modulus of x 2x square. Let x is equal to 0 plus h. As x approaches 0, h will also approach 0. Limit h will approach 0. 0 plus h. Modulus of 0 plus h. 2 plus h the whole square. So 0 plus h is h. This is modulus of h, which is also h plus 2h square. Limit h approaches 0, take h common. This is going to be 1 plus 2h. So h is gone. Now put the value of h as 0. So this is going to be 1. Okay. 1 second. I just made a mistake over here. Sorry. So this is minus 1 upon 1, which is minus 1. And here it is 1. Okay. Now see, this is equal to minus 1. This is equal to 1. So this value k does not really matter because LHL is not equal to RHL. So here only we come to know that the function is discontinuous. Okay. So we did not really bother about the value of k. And they are not asking us the value of k in this problem. They are saying that for any value of k, this will remain discontinuous, which is true because LHL and RHL answers are not matching. Okay. Let us go to question number 21. Fine. Question number 21. The function is undefined at x is equal to 2. I'll explain you the meaning of this. F of x is equal to 2x square minus 8 upon x minus 2. Now this function is not defined at x is equal to 2. So when x is equal to 2, this will be not defined. Okay, because 2 minus 2 will be 0 in the denominator. Okay, so x should not be equal to 2 over here. This is true only and only if x is not equal to 2. Okay, yeah. And when x is equal to 2, when x is equal to 2, what should be this value is what they are asking. Such that they are giving us that f of x is continuous at x is equal to 2. See, read the question multiple times. At x is equal to it is undefined. So this function is true only when x is not equal to 2. Then what value is to be assigned to f of 2? When I say f of 2, this is the value of x. So when x is equal to 2, what value should be given over here is what they are asking. Provided f of x is continuous at x is equal to 2. So since continuity is there, LHL is equal to RHL is equal to f of x is equal to 2. Okay. So now we are finding out this value. That means this particular value. Okay. So either we'll calculate LHL or RHL. Okay. Because it's not a proving problem. It is given it is continuous. So either find out LHL or RHL. So LHL limit x approaching 2 minus. Now the continuity is at 2. Don't take 0 by mistake. Okay. So this is less than 2. Now for less than 2 and greater than 2, the function is same x minus 2. Let x is equal to 2 minus h. As x approaches towards 2, h will approach 0. So limit h approaching 0, 2 into 2 minus h the whole square minus 8 upon 2 minus h minus 2. Okay, so this 2 and this 2 is gone. Limit h approaching 0, 2 into 4 plus h square minus 4h minus 8 upon minus h. Okay, down it is minus h. So simplify this. 8 plus 2h square minus 8h Okay, 8 plus 2h square minus 8h minus 8 upon minus h. So 8 and 8 is gone. So take 2h common. So within the bracket, we are having h minus 4 upon minus h. Okay. Now this h and this h is also gone. Okay. Now this was the final thing to simplify. Now put the value of h as 0. And down there is minus 1 because there is minus sign. Okay. So minus 4 upon minus 1, that is 4. 4 into 2 is 8. So we got the value of LHL as 8. Okay. So LHL is equal to 8. So what should be f of x is equal to 2? That is also equal to 8. So if I'm putting, or if I'm, one second, where have I copied the question? Yeah. So if this is equal to 8, then only all three values will be same. So this value f of x equal to 2 should be assigned which value? 8, because that is the LHL value. By RHL also you'll get 8 only in this problem. The reason being the function is continuous at x is equal to 2. Okay. Yeah. 22. Question number 22. The theme of the problem is same. Okay. F of x is equal to x square minus 1 upon x cube minus 1 is not defined at x equal to 1. So guys, if x is equal to 1 over here, 1 minus 1 will be 0. Okay. So x cannot take the value 1 over here. So this will be true if and only if x is not equal to 1. Okay. So f of x should be what when x is equal to 1? Also given, read the problem very clearly. F of x is continuous at x is equal to 1. Now since it is continuous, LHL equal to RHL equal to f of x equal to 1. Okay, equation number 1. Okay, now this we don't know. Okay, so which value should be given over here is what the question is. So you can solve any one. It's not a proving problem to solve both. Okay, solve any one, LHL or RHL. This time I will help you with RHL. RHL, limit x approaching 1 plus x square minus 1 x cube minus 1. Let x is equal to 1 plus h as x approaches 1, as x approaches 1. Okay, by the way, this is greater than 1. Doesn't really matter because the function is same. So as x approaches 1, h will approach 0. So limit h approaches 0, 1 plus h the whole square minus 1, and down 1 plus h the whole cube minus 1. Okay, now a plus b the whole square, a square plus b square plus 2ab, down a plus b the whole cube, a plus 3ab square plus 3a square b plus 3ab square plus b cube minus 1. So 1, 1, down also this 1 and 1 is gone. Okay. So we'll take h common in the numerator. Limit h approaching 0. Take h common within the bracket h plus 2, and down again you'll take h common 3 plus 3 h plus h square. After taking h common, 3 plus 3h plus h square. So h is gone. Now further simplification is not possible, so we'll put the value of h as 0. So the answer is 2 by 3. So this is RHL answer. So from 1, okay, f of x equal to 2, f of x equal to 1, okay, sorry, okay, this value will be nothing but any one of the values. And RHL we have solved, which is 2 by 3. By LHL also you'll get 2 by 3 only for this problem. The simple reason is the function is continuous at x equal to 1. Okay, let's go to question number 23. Yeah, question number 23. Is the function continuous at x is equal to 0? So let us understand this. F of x is equal to 3x plus 2 sine x upon x. I'll write x is not equal to 0 because if x is equal to 0, this function is not defined. So the function is true if and only if x is not equal to 0. So this is x greater than 0, x lesser than 0. Okay. They're asking whether this function is continuous or not. Okay. So one thing they have not given, this particular value at x equal to 0. Okay. So ideally we cannot really find out whether it is continuous or not at x equal to 0 because this value is not given. Okay. But then too, I'll first calculate LHL and RHL. Question is a bit ambiguous. Okay. So this is 3x plus 2 sine x upon x. Let x is equal to 0 minus h. As x becomes 0, h will also become 0. Limit h approaches 0. 3 into 0 minus h plus 2 into sine 0 minus h upon 0 minus h. So limit h approaching 0 minus 3h plus 2 sine of minus h upon minus h. Okay. Now you take this minus h and you split with the numerator a plus b upon c. So let's split this. So the next step will be limit h approaching 0 minus 3h upon minus h 2 sine minus h upon minus h. So minus minus is gone, h is gone. So we are left with 3 over here plus 2. Now this part is going to be 1 because h is approaching 0. Okay. So the formula we have used sine x upon x is equal to 1 where x is approaching 0. But then we need to mention one thing over here. As h approaches 0, therefore negative h also approaches 0. Okay. Which is equal to 5. So this is the LHL. Now RHL, limit x approaches 0 plus greater than 0, 2x plus 3x plus 2 sin x upon x. 3x plus 2 sin x upon x. Okay. Let x is equal to 0 plus h. As x approaches 0, h is also approaching 0. So limit h approaching 0, 3 into 0 plus h, 2 into sine 0 plus h upon 0 plus h. So limit h approaching 0, 3h plus 2 sin h upon h. Split 3h upon h, 2 sin h upon h. So h cancel and this part is 1. So this is equal to 3 plus 2 into 1, which is equal to 5. See now LHL and RHL are equal. In both the cases, we got 5. Okay. So to make it continuous, they're asking us to prove it to be continuous, but then LHL and RHL are same. Okay, which is equal to 5. So this has to be 5. Okay. See, they are saying to prove continuity, but then this value is not given only. And again, they are saying if not, then how many, how may the function be defined at x is equal to 0 to make it continuous? So to make the function continuous, we have to put this value as 5. So it is a bit ambiguous. They should have given this value and then simple and plain, they should have asked us to, prove continuity. But then without knowing this value, how we will prove continuity? Chalo, LHL, RHL we can do, which we have done also. But then we don't know this value. Okay, so how to prove continuity over here? That becomes a challenge, right? So let us solve one problem. Exercise 7A, question number 6. Sub question B. Okay. Now the nature of the problem is changing. Okay. So f of x is equal to 2x minus 1 when x is less than 0. F of x is equal to 2x plus 1 when x is greater than or equal to 0. Fine. Yeah. So this is given to us and we need to discuss the continuity or discontinuity at x is equal to 0. So first we'll find out LHN, left hand side limit, x approaching 0 minus. 0 minus is x less than 0. Now the function is not same. Okay. So x less than 0 is this function, 2x minus 1. So I'll just write 2x minus 1. Okay. Let x is equal to 0 minus h. As x approaches 0, h will also approach 0. So limit h approaching 0, 2 into 0 minus h minus 1. Now there is no denominator over here, so you can just put the value of h as 0. Okay. So this is minus 1 RHL. RHL limit x approaching 0 plus. We are discussing the continuity at x equal to 0. That is x greater than 0. 0 plus is x greater than 0. X greater than 0, this function 2x plus 1. Okay, so 2x plus 1, right? And let x is equal to 0 plus h. As x approaches 0, h will also approach 0. So limit h approaches 0, 2 into 0 plus h plus 1. Now there is no denominator, so you can just put the value of h as 0. Okay, and we cannot simplify also. Okay, so this is 1. Now in this particular case, LHL is minus 1 and RHL is plus 1 and both are not equal. Okay, so of course the function is discontinuous at x is equal to 0. Okay, right? And question number 6D. 6D and just a second. Yeah, so question number 6D is the last problem that I'm going to take right now. Question number 6D, f of x is equal to 5x minus 4 and f of x is equal to 4x cube minus 3x. So here x lies between 0 and 1 and here between 1 and 2. Okay, fine. So we need to discuss the continuity at x equal to 1. So they have given us the point at x equal to 1. So 1 becomes a critical point, and it is the critical point because at 1 the function is changing. Okay. So when x is less than 1 or very near to 1 and less than 1, then this function. Very near to 1 and greater than 1, then it is this function. And at x equal to 1 also, this function. Okay. So the function changes at x and near to x. So LHL, we need to find out. Okay. Limit x approaching 1 minus, which is x less than 1. So x less than 1 is this function, 5x minus 4. Okay. Now you know the method. RHL, x approaches 1 plus x is greater than 1. Okay. Now x greater than 1 is this function, 4x cube minus 2. Okay. And the third thing, f of x equal to 1, which is the first function itself, x equal to 1, 5x minus 4. Here there is no limit. Just put the value of x as 1. Okay. So you calculate the LHL value. Okay. You know the method now. You calculate the RHL value and this thing. All three should be same. If it is same, then the function is continuous at x is equal to 1. If it is not same, the function is discontinuous at x is equal to 1. Okay. Question number 8, you can solve it for self-study. Okay. So you have to, question number 8, you have to discuss the continuity at x is equal to half. So LHL at x is equal to half. Okay. Half minus. So half minus the function will be x less than half. X less than half is, if you refer the question, it is half plus x. Then RHL x approaching half plus. Half plus means x is greater than half. It is the third function in the problem, 3 by 2 plus x. Okay. And the last thing, x equal to half. X equal to half is 1. Okay. So all three things should be same. You can try this problem at your end so that you know there are no doubts. Or rather, if you practice it well, then you know you'll get the method to solve the entire thing. In case of any queries, you can get back to me. Yeah, thank you.